Greetings everyone. Today I'll be discussing how convolutional neural networks, CNNs, see a visual explanation of filters and feature maps. Imagine we have a small filter, say a 3 by 3 matrix of numbers, that acts like a stencil. We slide this filter over the input image, covering one small patch of pixels at a time. At each position, we multiply the filter's values with the pixels underneath and add them up to get one number. This process is called convolution. The filter is effectively looking for a specific pattern. For instance, a vertical edge filter has positive values in the middle column and negative on the sides. When this filter overlaps a sharp vertical line in the image, like the cat's ear, the multiply and sum output will be large. In other words, the filter lights up or activates on that pattern. In CNNs, these filters are not fixed beforehand. They are learned during training. Convolutional networks learn small 2D filters, often 3 by 3 or 5 by 5, that detect meaningful patterns. When we apply a filter across the whole image, we get a feature map, essentially a new picture of numbers. Each pixel in that map comes from one position of the sliding filter. In plain terms, the feature map shows where in the image the filter's pattern was found. For example, if we use a vertical edge filter on our cat image, the resulting map will have bright values, strong activations, along the cat's vertical contours, like the ears or the tail. Areas without such edges remain dark. In CNNs, each filter creates its own feature map. If a layer has, say, 8 filters, it produces 8 feature maps, stacked as channels. Together, these maps encode different simple features of the original image. Importantly, the filters stack. The first convolutional layer sees the original image and finds simple lines and edges, like the outline of the cat's ear or whiskers. We call these low-level features. Then the second layer takes those feature maps as its input and learns filters that respond to combinations of edges. For example, it might detect corners or curves by looking at where 2 edge maps overlap. These become mid-level features, like a round shape or a corner. By the time you reach the deep layers, the network is detecting high-level features, complex patterns that correspond to meaningful parts of the cat. Each deeper feature map is built from the ones before, so the network progressively builds a hierarchy of vision. As one article notes, the first few layers of a CNN are edge detectors. Deeper layers often learn to focus on specific shapes and objects. In summary, a CNN sees by using its filters to scan the image and generate feature maps. Each filter is just a learned 2D kernel that activates on a certain pattern. The feature maps it produces show where that pattern is present. Stacking many filters and layers lets the network detect edges first, then shapes, then full objects, like a cat's face. By visualizing filters and their feature maps, we get an intuitive picture of what a CNN is looking for in the image. This layered approach is why CNNs are so effective at image recognition. They literally build up what they see from simple pixels to complex concepts. Thank you for listening. Scan the QR codes below to visit my LinkedIn profile, GitHub repository, and Google Scholar page.